Hi, my name is Stan Forster, and we're going to be covering the volume of a cylinder. This is our Unit 9 objectives. We're going to identify the parts of a cylinder. We're going to apply a formula to find the volume of a cylinder. We're going to solve the formula for some unknown. Let's say we're given the formula, but not any of the inputs. One of the inputs. We can solve for that. Okay. Let's take and deconstruct the scale. You're going to have to identify the base and the height of a cylinder. And flat out, you just need to memorize the volume and the height. You just need to do that. Calculate the base given the radius or the diameter. Okay. Find the radius given the circumference or the diameter. Okay. So if you're given the base, area of the base, you can just simply use this formula. But if you're given the radius, you need to calculate the area of that base in order to plug it in. Otherwise, you could also be given the circumference and the diameter, and we'll show you how to do that. Okay, the circumference is 2 pi times the radius. We would simply, given the circumference, we would simply solve it for radius. Take that circumference, divide it by 2 pi, and away you go. The diameter, if you're given the distance across the base, that's the diameter. Okay, and it's twice the radius. So you would take that diameter, divide it by 2, and away you go. Okay, so what exactly is a volume? Okay, let's go back. Let's look at our cubes, and we know how to calculate the volume of a cube. We get the base. You take the length times the width, you multiply those together, that gives you an area, and then you multiply by the height. And so we're going to just use that. Volume equals base times height. We're going to just continue with that. It's applicable, widely applicable. It just happens that the base we're going to be working with is a little different. Okay. The main question, though, is are you given the area of the base, or do you need to calculate it? Okay, so if you're given the area of the base, you just multiply by the height, and away you go. Otherwise, you might be given the radius, and you might be given the circumference or the diameter. Okay. Now, for a cylinder, the base is not going to be square; it's going to be a circle. Okay, so this is a cylinder. It's a 3D figure with 2 equal circular bases that lie in parallel planes separated by a perpendicular distance h called the height. Okay, go over that again. Read that back to yourself. Pause it if you have to. Okay, we have a base down here, circular base on top and bottom. We have a height, the separation between them. All right, make sure you understand that, and we can go on to a much simpler model. It's a can. Okay, there's a can of black beans right there. Okay, it's a tuna fish can. Okay, the black bean can is really tall. Okay, the tuna fish can is kind of short, wider than it is tall. Okay. It's also a rocket. At its simplest form, the fuel tanks inside of a rocket are a cylinder. They're very long cylinders. Okay, and there might be some details like the top and the bottom might actually be rounded rather than flat. But basically, that's what we're talking about. Okay, and we're back to our formula. Volume of a cylinder is just simply base times height. Okay, so let's recognize the base and the height. Which is the line? Which line is the height? And think about that for a moment. Okay, so we have a red line there, and we have a blue line. Which of those is the height? And now you should pause this for a moment until you come up with an answer. But I'm just going to keep on going and let's see what we got. Remember, the height is still the perpendicular separation of the bases, even if the cylinder is on its side. So which color is the height h? Yeah, it's the blue line. The height is not always vertical. Very good. All right. Okay, so we're back to volume equals base times height. Sometimes the base, well, not always, for a cylinder, the base is a circle. And that area of a circle is pi r squared. That's review from our previous geometry. So let's go ahead and put it all together. Okay, I'm going to separate that out. We're going to put something in for that base there. Where the base was, that area of the base, we're going to plug in the area of a circle. So volume of the cylinder is pi r squared h. Okay, so why is that important? I'm going to ask you to memorize that. Okay, but why is it important? Because it's the basis of all the remaining formulas we're going to work with in this unit. Okay. Notice it says take notes. I want you to memorize this. Volume equals base times height. That's what we're working with. But we have the cylinder, which is pi r squared h. Okay, pi times the radius squared times the height. All right, but the cone is another one. We're going to have to memorize that one as well. It's 1/3 pi r squared h, and the sphere is 4/3 pi r cubed. Okay. Now, it may not look like it yet, but that formula for the cylinder is the basis of all of these. Let's go ahead and take a look here. Notice that the radius, okay, so for the sphere, think of a cylinder that contains a sphere inside of it. Okay, so that means that that the top and the bottom of the sphere touch the top and the bottom of the cylinder, and the sides, the circular great circle around the center of the equator of the sphere touches the sides as well. Well, if that height is going to be 2 times the radius, so let's go ahead and substitute that in. So we see h is replaced by 2r. Okay, it's in there now. We're going to move that 2. We're going to factor that out. We're going to move that 2 over here. Notice that the r squared times r became r cubed, and 2 times 2 is going to become 4. Okay, and there we're back to those formulas that I asked you to write down before. This is not new. If you wrote them down before, you've got it all. But look at that. Talk about what happens if we double the height. Okay, when we were on the submarine, we took a lot of food with us. We came in these number 10 cans, and we would stack these things everywhere. We would put them on the decks and then put plywood on top of them, and we would be walking on food until, well, we started to use it up. Well, what happens? We're going to put these cans everywhere we can, and we're going to end up with can on top of can. And so you can look at this. If we double the height, all we've done is it's like 2 cans. If we double the height, so what happens to the volume? Well, if you double the height, you've doubled the volume. Okay, what about triple the height? How many cans tall is that? And that'll tell you exactly what happens to them. How much volume does 3 cans hold as opposed to just 1 can? Okay. Come to think of it, a submarine, it's a can. It's a cylinder. Okay, there's all this stuff on the outside, but the important stuff is all sitting inside a watertight cylinder that we call the people tank. Okay. So what happens if we double the radius? Okay, I've taken the base and we've doubled that radius there. Let's figure out what happens when you double the radius. So what's the ratio of the second volume, the increased volume, over the first volume? So we're going to actually divide that out. We're going to take volume 2 divided by volume 1, and we're going to see what comes out. Well, it's still pi r squared h and pi r squared h, except that the second radius is twice the original one. So on top we have pi times 2, inside parentheses, 2r squared. I'm going to square everything in those parentheses, times h. And on the bottom, there's going to be some cancellations. But let's see how this goes. First of all, we're going to square everything inside the parentheses. So the square of 2 times r is 2 squared times r squared. Okay, 2 squared. We're going to move that 2 squared out front. And we're starting to see something that can be canceled. This is pi r squared h on the top and pi r squared h on the bottom. Look at that. Yeah, something divided by itself is just 1, and we can drop it. And 2 squared is, of course, 4. Okay. And that's the general rule. It says increasing the radius by n increases the volume by n squared when you increase the radius. Okay. Let's go back. Let's take the second volume was 2r. We're going to square that quantity in parentheses, 2r squared. What happens if we tripled the volume? This 2 would be a 3, and then 3 squared is 9. So tripling the volume would have increased tripling the radius would have increased the volume by a factor of 9. Okay. All right. Here's something I want you to work out for yourself. What happens if we cut the height in half, or the radius in half? Okay, you've got all the tools you need for that. If you're not able to figure that out, find me in the discussions, find me on Teams, and we will go over it. Okay? Have a good one.